Hi guys, welcome to another awesome video with myself Sam Pele, and today we are continuing with the Gauteng June exam for 2023. And if you haven't subscribed yet, what are you waiting for? Just make sure that you hit the subscription button so that you are aware whenever I post questions. Today we are continuing with question 2 and 3, which is sequence and series. And just before we start, I would like to just make you aware of the fact that last year's June exam had an errata. So there was a mistake on the paper, actually a typing error in question 3.2, where 3.2 had a typing error. So we're going to ignore that question, and actually the question paper was marked out of 150 instead of 120. So without waste of time, let's just go straight to the questions. And over here I have question 2, and it's a geometric series with the sum of the first n terms is given by that expression, and we have a sum to infinity which is 10. So 2.1 wants us to calculate the values or the value of k. So in 2.1 here, the information that we're given is that Sn is equal to that expression there, but we know that S1 is equal to A, so we need to find A. So A is equal to k 1 minus 1 over 2 to the exponent 1. And 1 over 2 to the exponent 1 is 1 over 2, and then subtract 1 minus 1 over 2, which now means it's 1 over 2k. So meaning A is 1 over 2k. So that's the first thing that we use. And then now we are given that the sum to infinity is equal to 10. So we know that sum to infinity has the equation S infinity is equal to A over 1 minus R. So we need to substitute that. And what we have here is that 10 is equal to, now remember, A is 1 over 2k, 1 minus, and then R is 1 over 2. So now we have over here 10 is equal to 1 over 2k divided by 1 minus half is going to be 1 over 2. Now 1 over 2 cancels 1 over 2, and then 10, and then is equal to k, so meaning k is equal to 10. So we have found the value of k. And for 2.2 here, calculate the second term. Now the second term, remember, is T2, so we need to find T2. And now if we have A and R, remember T2 is AR, so we need to substitute A and then substitute R. So our first term is given by remember, A is equal to 1 over 2k, and we found that k is equal to 10, so A is equal to 5. So that would mean A is equal to 5, so we can substitute our 5 here, and then our R is 1 over 2, and that would be 5 over 2. So the value of A is 5 over 2. We can move on to the next question. Prove that, this is question 3, prove that in any arithmetic sequence or series in which the first term is A, whose constant difference is D, the sum of the first n terms is given by that. So meaning that you need to prove the sum of an arithmetic series. Now guys, remember we have two equations that we need to write, but one is the first one written in reverse, so meaning Sn is equal to, now in an arithmetic, remember we have the first term is A, the second term will be a plus d. Then the third term will be what? Will be a plus 2d. This continues like this, and then plus the second last term is a plus n minus 2d. This is square brackets plus, and then the last term is a plus n minus 1d. So this is your first equation, equation 1. Let me not say equation A. Let me just erase this here. So this is your equation 1, and what you need to do here, you need to write equation 1 in reverse. So Sn is equal to, the first thing that you're going to write is the last term on the first equation. So this would be a plus n minus 1 d plus a plus n minus 2 d, and we continue to a plus 2d plus a plus d plus a. This is your equation 2. Now the next step here, you need to add these two equations here. You need to add these two equations here. So now Sn plus Sn would be 2Sn is equal to, now when we are adding all of these, what we'll have is, we don't know how many they are, so there's n number of them, and when we are adding like terms here, we'll have 2a, we'll have 2a. So if we had added the a and the a here, we'll have 2a. So here's 2a plus n minus 1d. So there's infinite numbers of 2a plus n minus 1d. Then what we can do now is divide both sides by 2. If we divide this side by 2, then we'll have Sn here, and then if we divide this side by 2, we'll have n over 2, and then we'll have 2a plus n minus 1d. So that is how you prove the sum of an arithmetic. It's very simple. Equation 1 is straightforward. Then you write equation 1 starting with the last term, and then you add the like terms, and you divide by 2, and then you will have your proof. So very simple there. Let's just go to the next question. So for the next question, we are given sigma notation, and we have something like this: p is equal to 1 and then 50. Now with sigma notation, remember this, it will be the end or the last term, so I like calling it the end, and then this will be your start. And our Tn here is 100 plus 100 minus 3p. So this is your Tn over here. This is your Tn. And remember, when we have sigma notation, sigma here means sum. So it can be the sum of an arithmetic, or it can be a sum of a geometric. But how do you find out? You expand the sigma notation. Now when you're expanding the sigma notation, you keep substituting p. Remember, p equals to 1. That's your start up until 50. So now what we need to do is substitute p as 1, p as 2, p as 3. So now if you substitute p as 1 here, what we'll have here is that our first term will be 97. So we've substituted 1, right? Then the next time we substitute 2, we'll have p being 94, you substitute 3 p, and then now the thing will be 91. So every time when you see sigma notation, just substitute until you get 3 terms, so that now you can differentiate whether is it arithmetic or is it geometric. So now I've substituted 1, and then I've substituted 2, and I got 94. When I substituted 3, I got 91. But what I notice here is that I have a common difference of -3 here, -3, so meaning that it is arithmetic. So we know that the sum of an arithmetic series is Sn is equal to n over 2 2a plus n minus 1 d. So we know that our a is the first term, so a is equal to 97, and then we have d is equal to -3. Now with sigma notation, it's very important that you know number of terms is different. Now this doesn't represent number of terms because this can always change. So we know we have to say end minus start plus 1. So our end is 50 minus our start is 1 plus 1, which is equal to 50. So n is equal to 50. So now what we can do here, we can say the sum of 50 terms is equal to 50 over 2, and we have 2 times our first term is 97 plus 50 minus 1, and then our difference is -3, which now if we substitute into our calculator, we'll find that our answer is 1175. So that is how we solve our question. Let's move to the next question here, and this is our last question for sequence and series, and we are given 3.3. A quadratic sequence is defined with the following properties: t2 minus t1 is equal to 7, t3 minus t2 is equal to 13, t4 minus t3 is equal to 19. And then the question says write down the value of t4 minus t5 and t, if you can't see this is 70 minus 69. So obviously this is a quadratic, and this is t1, we have t2, we have t3, so t1, t2, t3, t4, and then they say t2 minus t1 is 7, t3 minus t2 is 13, and then let me just fix my 7 here. This looks a bit funny. So t4 minus t3 is 19, and we all know that a quadratic has a common difference. And if you look at a second difference, so if you look at this quadratic here, our second difference here would be 6. So fine, the first question says write down the value of t5 minus t4. So t5 minus t4 would be the second term here, so we just add 6 to 19, which would be 25. So this is 25, and then now we need to find t70 minus t69. Now if you look at the relationship between the quadratic and the first difference. The first difference here is arithmetic. So the first difference is arithmetic, meaning it has a common difference of 6. So meaning that this first difference has t n is equal to a plus n minus 1 d. Now the difference in the two sequences is that t2 minus t1 gives you the first term, then t3 minus t2 gives you the second term, t4 minus t3 gives you the third term, then t5 minus t4 gives you the fifth term. So over here, if we have t70 minus t69, it will give you 69. So it will give you t69 on this sequence here. So what we can do is find t69. Our first term here is 7 plus 69 minus 1, and our difference here is 6. So we can just use a calculator and substitute that, and we'll find that our answer is 415. So very simple there. Let's just do a recap of how we answered our questions here. We started off with question 2. Question 2, we were asked to find k. We were given the sum to infinity and also a sum expression for the sequence. Now if you look at your mark allocations here, you get a mark for finding a, which is 1/2, and then you get a mark for substituting r as 1/2 into this sequence here. You get a mark for substituting into the correct formula for sum to infinity, and then you get a mark for finding the value of k, which is 10, and that is in total your 4 marks. Then for the next question, we had to find the second term. For the second term, you get a mark for substituting the correct ratio. So correct ratio, you get a mark there. Correct substitution to the formula AR, you get a mark there. And then you get a mark for finding a, which is 5. That's a mark, and then you get a mark for your answer there. So in total, that is your 8 marks. Then we move on to the next question. When we are proving the sum to an arithmetic sequence, your first mark there is for your first equation or your first series, and you get a mark for reversing this series, and then you get a mark for adding them, and then you get a mark for dividing by 2. Now guys, I have to say this is free marks. Now remember, if you can just know how to write the series in the right form, then writing it in reverse, it would be easy. Adding them would be easier, and then dividing by 2, this is a free 4 marks. Let's just go to the next question. Over here we were given sigma notation, and then we needed to find the sum of that sigma notation. So over here you get a mark for the value of a, which is 97. You get a mark for the value of d, which is 93. You get a mark for substituting, or you get a mark for the n value, which is 50, and then you get a mark for the answer, and that is your 4 marks. And also here it's also 4 marks. your last question, we had to find T5 minus T4, and that was 1 mark. Get a mark for the 25. We had to find T79 or T70 minus T69, and then you get a mark for substituting into the correct formula. You get a mark for also knowing that the n is 69, and then you get a mark for the answer. So that is your 3 marks. And I hope you enjoyed the video and you gained a lot, and I'll see you on the next video. For myself, bye.